Good morning, dear students. In previous class, we were discussed about what is meant by resistance. Resistance means the property of a conductor by virtue of which it opposes or resists the flow of charges through it. SI unit is ohm, and resistance of a conductor is given by R is equal to potential difference divided by current. It means R is equal to V by I. And afterwards, in which factors are responsible for the resistance of a conductor depends, in which first one is length of the conductor. It means resistance of a conductor R is directly proportional to its length, small l. It means R is directly proportional to L. Second, area of cross section of the conductor. It means resistance of a conductor R is inversely proportional to its area of cross section A. Yes, it means R is inversely proportional to 1 upon A. And third one, our third factor is nature of material of the conductor. Yes, my dear students, it means the conductors, so resistance of a conductor depends on the nature of material which it is made. And afterwards, what is meant by resistivity? And resistivity SI unit. And afterwards, insulators, some common examples of insulator, and high resistivity insulator as well as low resistivity insulators, and definition of alloy, and some examples are concerned alloy. Next, resistors in series. It means when two or more resistors are connected end to end to each other, then they are said to be connected in series. Finally, we got resistors in series R is equal to R1 plus R2 plus R3. Yes, today let us see one example, solved example given in our textbook concern resistors in series. An electric lamp and electric lamp whose resistance is is 20 ohm and a conductor of 4 ohm, resistance are connected to a 6 volt battery. Calculate first the total resistance, of the circuit B, the current through the circuit, C, the potential difference across the potential difference across the electric lamp and conductor. Electric lamp and conductor. Yes, my dear students, see once again what is given means question. An electric lamp whose resistance is 20 ohm and a conductor of 4 ohm resistance are connected to 6 watt 6 volt battery. Calculate A, the total resistance of the circuit, B, the current through the circuit, C, the potential difference across the electric lamp. Yes. Solution. First, given R1 is equal to 20 ohm. It means the resistance of electric lamp R1 is equal to 20 ohm and the resistance of the conductor connected in series R2 is equal to 4 ohm. The total then the total resistance in the circuit is A R is equal to R1 plus R2. So, what is given here? R1 20, R2 is 4. It means total resistance is 24 ohm. Yes, my dear students. The total potential difference across the two terminals of the battery V is equal to how much? V is equal to R is equal to 24, V is equal to 6 volt. Okay. Now, by Ohm's law, I, it means current is equal to V by RS, means what is given? V is 6 volt divided by RS is 24 ohm. Yes, my dear students. Okay, now start calculate. 6 24, yes, 0 0, yes, 24 2 za 48, means 1 2, then take 0, 24 5 za 120. Yes, it means answer is I is equal to 0.25 ampere. Yes, I is equal to 0.25 ampere. 0.25 ampere. Yes, my dear students, applying Ohm's law to electric lamp, applying Ohm's law to the electric lamp, and conductor separately, we get potential difference across the electric lamp. V1 is equal to 20 ohm into 0.25 ampere. Yes, 20 into 0.25 means it is 5 volt. Yes, V1 is 5 volt, and to that across the conductor across the conductor V2 is equal to 4 ohm into 0.25, 4 ohm into 0.25. 4 ohm means R2. It means the resistance of the conductor connected in series R2. It is equal to V2 is nothing but how much? 1 volt. Okay. Suppose that we like to replace the series combination of electric lamp and conductor by a single and equivalent resistance. Its resistance must be such that a potential difference of 6 volt across the battery terminals will cause a current of 0.25 ampere in the circuit. The resistance R of this equivalent resistance would be R is equal to V by I, potential difference as well as current is much given here 6 volt divided by 0.25 ampere. Yes, my dear students. Yes, it means we remove decimal point in denominator, then we take 2 0 in numerators. Yes, 6 into 100 divided by 25, 25 ones are 25 fours are. Yes, it means 6 into 24, sorry 6 into 4, 24. Yes, the answer is 24 ohm. Yes, this is the total resistance of the series circuit. It is equal to the sum of the two resistances. Yes, my dear students. Statement. What is statement? This is the total resistance of the series circuit. It is equal to the sum of two resistances. Yes, my dear students, it is clear? Yes. After discussing and solved example, let us see next discussion point. Resistors of parallel. Yes, my dear students, today let us see resistors in parallel. Yesterday period discussed resistors in series. Yes, here the definition of resistors of parallel: when two or more resistors are connected simultaneously between 2 points to each other. Yes, what is resistance in series? When two or more resistors are connected end to each other, then they are said to be connected in series. But in parallel, two or more resistors are connected simultaneously between 2 points to each other, then they are said to be connected in parallel combination. Yes, when two or more resistors are connected simultaneously between 2 points to each other, then they are said to be resistors are connected in parallel combination. Resistors in parallel combination, in parallel combination. Yes, my dear students, it means here more than two resistors are connected simultaneously between 2 points to each other, then they are said to be resistors in parallel combination. Yes. Parallel combination. R1, R2 and R3, voltmeter, key and potential difference, positive, negative, ammeter. Yes, my dear students, it means here three resistors are connected simultaneously between 2 points. Yes, connected between what? 2 points. Here said to be what? Resistors are connected in parallel combination. In parallel combination, flowing. This indicates what? A current I. Yes. The following figure shows the connections of resistors in parallel, and applied potential V produces current I1 in R1, I2 in R2 and I3 in R3. Yes, and applied potential V produces current I1 in R1, I2 in R2, I3 in third resistor R3. Yes, then total current I is equal to I1 plus I2 plus I3, I1 plus I2 plus I3. By applying Ohm's law, Ohm's law, Ohm's law, I1 is equal to V by R1 I2 is equal to V by R2, I3 is equal to V by R3. Yes, if R is equivalent resistance, if R is equivalent resistance, then I is equal to V by R. Okay. Thus V by R is equal to V by R1 plus V by R2 plus V by R3, V by R3, V by R3. Yes, from equation 1 we get, from equation 1 we get, equation 1 is I is equal to I1 plus I2 plus I3. Yes, we get what? V by R is equal to V in bracket 1 by R1 plus 1 by R2 plus 1 by R3, 1 by R3. Okay. Then it is nothing but 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Yes, my dear students, resistance in parallel or resistors of parallel. 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Yes, some important points regarding parallel combination of resistors are: the reciprocal of equivalent resistance is equal to sum of the reciprocal of individual resistances. The equivalent resistance is less than the resistance of either resistor. This is known as minimum effective resistance. The current from source is greater than the current through either resistors, and also the potential difference across each resistor is same. Yes, my dear students, what are the applications of, the main applications of parallel combination? Parallel combination of resistance is highly useful in circuit used in daily life, as the circuit used have components of different resistance requiring different amounts of current. This type of combination in a circuit divides the current among the component, it means electrical gadget, so that they can have necessary amount of current to separate properly. This is the reason connecting electrical appliances in parallel combination in household circuits. Yes, my dear students, these are the applications of parallel combination of circuits or resistors. Yes. Thus, we may conclude that the reciprocal of the equivalent resistance of a group of resistance joined in parallel is equal to sum of the reciprocals of individual resistances. Yes, my dear students, let us see. Yes, let us see one solved example given in our textbook concern parallel combination. Example: in the circuit circuit diagram. In the circuit, suppose the resistors R1 comma R2 and R3, R1 comma R2 comma R3 have the values 5 ohm comma 10 ohm comma 30 ohm respectively, which have been connected to a battery of 12 volt. First calculate a the current through each resistor, each resistor. B, the total current in the circuit, C, total circuit resistance, Yes, my dear students, a given example. In the circuit diagram, suppose the resistors R1, R2 and R3 have the values 5 ohm, 10 ohm, 30 ohm respectively, which have been connected to a battery of 12 volt. Okay, calculate first one the current through each resistor, second the total current in the circuit, and third the total circuit resistance. Yes. Okay. Solve this problem now. Solution. Yes, R1 given, R1 is 5 ohm, R2 10 ohm and R3 30 ohm. Yes, battery P is equal to 12 volt. Yes, first this is also the potential difference across each of the individual resistor. Therefore, to calculate the current in resistors, calculate current through each resistor, we we use Ohm's law. Yes, we use Ohm's law. It means I1 through R1, Yes, first one I1 is equal to, afterwards applying what? Ohm's law. I1 is equal to V by R1, means given that as a 12 divided by 5, 12 divided by 5. Yes, five to the 0, 2, 1, 0, 5 for the. Yes, mean answer is I1 is equal to 2.4 ampere. I1 is equal to 2.4 ampere. Yes, second I2 is equal to V by R2, 12 divided by 10, 12 divided by 10. Yes, 10 ones are 10, 2, 0, 10 twos are 20. Yes. It is equal to 1.2 ampere. I2 is equal to 1.2 ampere. Yes, next find out I3. I3 is equal to V by R3. V by R3. It is equal to 12 divided by 30. 12 divided by 30. 30. Okay. Take 0. 30. 4 is 120. Yes, it is equal to 0.4 ampere. So, I3 is equal to 0.4 ampere. Yes, my dear students. Yes, now the total current in the circuit. The total current in the circuit. I is equal to I1 plus I2 plus I3. Yes, data are I1 is 2.4 plus I2 is 1.2 plus I3 is 0.4. Yes, totally 4 ampere. It means the total current in the circuit I is much 4 ampere. Yes, my students. Now find out the total resistance Rp. The total resistance Rp 1 upon Rp is equal to, yes, given data are 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. It is equal to 1 divided by R1 5 plus 1 divided by 10 plus 1 divided by 30. Yes, take LCM, totally 30. 6 plus 10 3s plus 30 1s, totally 6, 10 divided by 30, 10 1s, 10 3s. Yes, it is equal to 1 upon 3 or thus Rp is equal to 3 ohm. Rp is equal to 3 ohm. Yes, my dear students, today's class we all are discussed and solved problem on series combination, and afterwards what is meant by parallel combination or parallel connection, and also